to be bound in the nicotinic receptors in the nervous system of an organism. This group of insecticides, they possess outstanding potency and systemic action against person-sucking insects of agricultural crops, and also for insects that are attacking our pet animals like cats and dogs. This group of insecticides, the neonicotinoids, they are a broad spectrum. They are effective against insects of different feeding habits. They are effective against chewing insects like that of the lepidopterans and coleopterans. But they are also effective against sucking insects like those of the bugs. And in terms of toxicity, this group of insecticides are considered less toxic to mammals, but more toxic to insects. What makes it more toxic to insects? It is in the insects that there are more abundant receptor sites, and in this case, the neonicotinoids block a certain neural pathway. If you compare it with insects and warm-blooded animals, including human beings, it is more than vertebrates. We already discussed that this group of insecticides are quite effective against chewing and sucking insects, but this in general observations or findings. And how about the crops or the substrates? They are effective as a form of insecticide. With their broad spectrum activity, they are effective against soil-borne insects. They're also effective against insects infesting seeds, especially those seeds are used as seed as seeds for planting materials. Then there are also those insects that infest timber products, like for example the powder post beetle. Neonicotinoids are effective against them. And there are also animals that are harboring a number of insects. Well, these neonicotinoids are also proven to be quite effective. Okay. Any? Yeah.
Admit daw si Donay.
Okay.
Admit daw si Donay.
Yeah.
Thank you.
Good afternoon, Carol.
Good afternoon, ma'am.
Okay. Okay. Let's continue. With this broad spectrum activity, these neonicotinoids are quite effective in this following crops that I will be mentioning, like cereals. Cereals, this comprise the rye, oats, wheat, millets, and other cereals, not indicated here. Then we have cotton, grains like rice and corn. Then we have legumes. For legumes, we have soybeans, we have peanuts, we have beans, and any other crops belonging to family Leguminosae or Fabaceae. Then we have potatoes, we have pome fruits. Pome fruits actually are fruits comprising apples, pears, nectarines, and other fruits belonging to the same category. Then we have also for rice as as components of grains. Then we have vegetables, a number of this, including the vegetables grown in the tropics and subtropics, and turfs. Turfs, maybe you don't, it could be your first time or you can heard about it. Turfs are grasses that are intended in golf courses. It is a specialized grass used in golf, and turfs are not free of pests. There are a number of soil-borne insects that attack the roots of, and neonicotinoids had been proven to be effective for a wide range of insects, from cereals down to turfs. How this activity of neonicotinoids as an insecticide started? It was the work of Professor Henry Foy of Purdue University in Pennsylvania, USA. He started the work of neonicotinoid, and this led to the discovery of imidacloprid, the first neonicotinoid that came out in the market. During the work of Professor Foy, he did a lot of synthesis to come up with different chemicals, and one of the compound he produced was given to Shell Chemicals for insecticidal testing. Shell Chemicals is one of the leading pesticide company in the world. During that time, in 1990s, Professor Foy requested Shell Chemicals to do bioassay for the insecticidal testing of his neonicotinoid produced, and it was found out that that product was insecticidal, but its activities was quite weak in many common insects, and the basis to come up with more improved products with better specificity and also with longer persistence in the field. We know that nicotinoid as a compound is highly degradable. It is easily decomposed in the presence of light and also after exposure of high relative humidity and higher temperature. The weakness in it, the weakness of nicotine as well as the weakness of all other compounds produced by Henry Foy was re-examined, and the biological and chemical activities were further studied, and a lot of explorations were done, leading to the discovery of nitromethylene heterocycles. Nitromethylene, it is the nitrogen in the methylene part of the molecule in the whole heterocyclic compound. Now, this is the one here that are being produced from the work of Professor Foy in 1990. A number of leading pesticide companies participated in the production of neonicotinoids, but it was Nahon Bayer, one of the conglomerates of Bayer Chemicals in Germany, merging it with Nahon Chemicals. This company was able to produce a number of neonicotinoids, starting from imidacloprid in 1983, while the work of Foy started his work was discovered in 1990. It took 13 years after when the first neonicotinoid, imidacloprid, came out in the market, after making a lot of improvement from the first neonicotinoid produced by Professor Foy. Nahon Bayer produced 4 neonicotinoids from 1983 up to 1992. We have imidacloprid, nitimpiram, acetopramide, thiamethoxam. Now, imidacloprid is quite effective as insecticide, especially for many insects, including those of livestock, animals, and pets. Thiamethoxam is the most of all these four neonicotinoids produced by Nihon Bayer, it is thiamethoxam that gained a lot of uh, sales all over the world, and it is still popularly used at this time. If you look at the structures of the first four neonicotinoids produced by Bayer, Nihon Bayer, you try to examine how these different insecticides look like in terms of structure. Here, imidacloprid and thiamethoxam, they maintain these heterocyclic rings, but there are some modification each of these rings. Yeah. Say for example, in imidacloprid, it has this furan ring, but here in imidacloprid, it is nitrogen is incorporated. Here we have one nitrogen plus one sulfur in it, and it lacks now the amine part, the amino part in this part of the molecule, and this benzyl, this this ring here, the benzyl ring, one of the carbons is substituted with nitrogen. Then there's a chlorine that is incorporated in this ring. Here it is a nitro ring, so all with nitrogen here plus a metal part instead of a chlorine in here. No? And for nitempyran rings, this furan ring, it is now opened, and you have a nitro and a nitro substitutions in this open part of the molecule. In the same manner, if you look at acetamiprid over nitempyram, you have here the same part of the molecule. This part is also the same, except that the methyl part is being removed, and in here you have also this part wherein you have an amino part being incorporated, but here it is the nitroamine, no, with these three bonds here. If you are going also to compare this full group of neonicotinoids, you would also find some differences now. This part of the molecule, the ring part is open, but here it still maintains thiamethoxam, and clothianidin maintains the same structure, but the end here is being what is the difference here? This is the same thia, wherein you have sulfur that is incorporated, but what differs is in this part here, where in this one and thiamethoxam you have a closed ring here. Here it is already open. Then the notifuran is a very simple kind of neonicotinoid. What is being maintained is this ring. Instead of having a double ring and being halogenated plus the incorporation of sulfur, it's only oxygen that is incorporated in this furan ring, and the rest of this part of the molecule is maintained. This denatifuran was developed by Metsue, while clothianidin was developed by Takeda chemical manufacturing firm. Bayer, the mother unit based in Germany, was able to make another product, thiacloprid. If it is thiacloprid here, what it is the same imidacloprid. What is being substituted actually is this in here with sulfur. That's the only difference. You have to remember that any words that contains THIA, it signifies that there is a presence of sulfur. in the molecule. Now, what is the mode of action of neonicotinoids? Since it is based on nicotine, and it is just an improvement of the nicotine as an insecticidal compound, so definitely it has similar mode of action with that of the nicotine, wherein both compounds, nicotine and neonicotinoids, would act on the central nervous system. In the central nervous system, it is the nicotinic acetylcholine receptors that are involved in the mode of action. These are, it would affect the nicotinic acetyl receptors, and also binding the sites of and also the binding sites of neonicotinoids. Now, the nicotinic acetylcholine receptors are present in many organisms. It is a common receptor sites, but for neonicotinoids, it is also the same binding sites with this one. In so doing, it would compete now with the acetylcholine, in which this is a compound that is involved in the neurotransmission of impulses in the synapse. These nicotinic acetylcholine receptors, not necessarily in the synapse, but part in the nervous system. These nicotinoids can easily bind in these sites. By binding, instead of the acetylcholine that is acting in the system, it is now the neonicotinoids. Binding of neonicotinoids in the nicotinic acetylcholine receptors would form a neonicotinoid acetylcholine receptor nicotinic acetylcholine complex. And with this new products that are produced, the action of acetylcholine could no longer be in a normal state. It is now the action of nicotinoids that is prevailing in the nervous system. With this group of insecticides, the neonicotinoids, part of the molecule of the nicotine is substituted with cyano or amino group in their structure. And these two elements here, they have electronegative tip that allows selectivity by binding to a unique cationic subsite of the insect receptors. The insect receptors, you have their cationic subsite, but in the mammalian receptors, it is very specific to a protonated to the protonated nicotinoids. While the action of both are the same, but the type of binding varies. Here, it is for the insects, it is in the cationic subsite. In mammals, it requires a cationic interaction before the binding will proceed in the nicotinic acetylcholine receptors of mammals. This kind of action makes neonicotinoids as more selective towards insects and not to mammals. If its activity is quite selective, then we know that it is less toxic to mammals than to insects. The structure of neonicotinoids has a closer mimic to the insect's acetylcholine than the acetylcholine in humans. With this close mimic to to the acetylcholine in insects, it is the one that makes it more specific to the insects and less ability to become a poison to humans. This is a good development wherein we are looking for insecticides that are quite effective with broad spectrum activity and lower mammalian toxicity. The more selective to insects than mammals in terms of the mode of action, it is because neonicotinoids block a specific neuron pathway that is more abundant in insects than in mammals. And one of these is actually that of the receptors that it contains more in insect than in mammals. The low affinity of neonicotinoids in terms of toxicity towards vertebrates, that they are that is one of the advantages of neonicotinoids over other group of insecticides. This makes a big contribution of this group of insecticides for the rest factor, wherein the low affinity of this particular group of insecticides make it a favorable kind of insecticides with such kind of toxicological profile. Now, its toxicological profile is this. It is more toxic to the insects and less toxic. And if there is a lower toxicity to the mammals, then it is more specific to the insects. And while it is very specific to the insects and not to mammals, it can be answered with the presence of this nature of acetylcholine in insects with that of the mammals, and the competition of the nicotinic acetylcholine receptors in insects that are more abundant than in mammals. That is it. And in terms of that toxicity towards non-target organisms, including us, this particular group of insecticides are considered less toxic when absorbed in the skin. So there is less dermal toxicity, and it is also less toxic when inhaled, but it is more toxic when being ingested. For insects having different kinds of feeding behavior, be it a sucking or piercing type of insects and chewing type of insects, the nature of neonicotinoids that is systemic, then these insects that are exposed to treated plants are able to ingest the neonicotinide laced plants for food, and especially for the chewing insects, but for the sucking insects, its systemic activity would provide access for the sucking insects to imbibe those neonicotinoids that are already incorporated in the plants. In the study of mammalian toxicity, it's not wise to study its toxicity using human beings. So one of the animals that are used in mammalian toxicity test is rats and other higher form of rodents like rabbits. But in the study of neonicotinoids, it was done in rats. And after these rats receive neonicotinoids at different concentrations, so if the concentration is already reaching the lethal dose, these rats would show lethargy. It's a weakening of the body. Then there were also respiratory disturbances that were observed, decreased movement, and staggering gait. Gait is the manner of walking. If it is staggering, then it would shift from left to right, no longer having a straight walk. Then other those receiving higher concentration and exhibiting advanced stage of intoxication would show trembling and spasms of the body. What are the target pests where we can use neonicotinoids? Since their discovery and also the first time they were out of the market, the use of neonicotinoids has grown tremendously all over the world. It is one of the most sought by growers or by farmers, especially if there are already development of insect-resistant um, pest populations after using those four kinds of insecticides we had previously discussed, from organochlorines to down to pyrethroids. Um, I have already mentioned that it is a kind of insecticide with systemic action, and this characteristic would be good for person-sucking insects of agricultural crops. And it is not only limited to sucking insects, but it is also quite effective against coleopteran insects like beetles or even weevils. And in addition, lepidopterans too actually uh, are actually susceptible to neonicotinoids, especially cutworm. Now, its utilization does not limit only to this persing, sucking insects and also chewing insects of agricultural crops, but they are also used to control insects of other products and other situations. Neonicotinoids are used against soil-borne insects. They are also used as protectant for seeds that are intended for planting materials. They are also effective against insects attacking timber like the powder post beetle and other insects. And neonicotinoids even they are even used on animal pests for many animals of economic importance, be it poultry and livestock or even hogs, where there are a number of insects that are harboring with this kind of animals. Um, neonicotinoids there are neonicotinoids that are formulated in a solid form that is used in seed treatment or even in timber, but there are also formulations wherein neonicotinoids are applied as foliar sprays. When it is applied as foliar sprays, they are effective against insects attacking cereals, cotton, grains, legumes, potatoes, palm fruits, rice, vegetables, and herbs. Now, for cereals, these include wheat, rye, barley, oats, and millets. And for grains, this also include that of corn and rice. I have already mentioned here rice, but there are also other grains like the pulses. Then legumes are also included here. Palm fruits are the apples, pears, nectarines, and other fruits that belong to the same family. Then we have a number of rice pests that are effectively controlled by neonicotinoids. There are also a number of insects attacking vegetables and quite sensitive to neonicotinoids as well. In terms of turfs, this is used for the golf industry, and there are many soil-borne insects that are affecting it, and it is one of the most expensive sports, and they cannot afford that even part of the turf is being damaged by insects. It would affect the what you call this the activities in such kind of sport. Okay, now that is it. For neonicotinoids, we have finished it in 30 minutes. And we will spend 10 minutes for the discussion. So I hope you learned something from it. But I have to add again, not necessarily added in this discussion, I have to mention that neonicotinoids are actually banned in many developed countries since neonicotinoids had been traced as one of the culprits in the phenomenon so-called bee decline. In the bee decline, the population of bees was drastically reduced, and they were looking why why the population of bees keep on declining. It was found out that these bees, which are pollinators, would also gather pollens in flowering plants that are sprayed with neonicotinoids such as thiamethoxam, and these pollens are brought to the hive of the honeybees, and then it is gathered by bees as food for the developing youngs. These developing youngs will get intoxicated by neonicotinoids, and eventually only there is a higher mortality rate that are observed. Even with this condition, it's already alarming for beekeepers and also for agricultural production in temperate countries. The role of honeybees in temperate countries is very important, especially in crop production. Now, in temperate countries, they have winter. During winter, there is no development of bees under natural habitat. They are still alive, they are present, but in a diapause stage, they undergo hibernation, and they seek even warmer shelter. In order to solve the problem during the next cropping season in spring and summer, farmers in these temperate countries would need augmentation of honeybees for pollination in their farm. Well, there are already honeybees that are coming out from their niches after winter, especially in the spring form where there are already lots of blooms in many flowering plants, be it in the meadows or grown in agricultural production. And during this time, the initial population of bees is quite low. These farmers would normally acquire bees to be released to their fields. And in our country, it is not the case. In other countries, honeybee production or apiculture is intended for two aspects. One is for the production of honey, which is a lucrative business. The other one is for the production of honeybees for pollination. For apiculturists in these two countries, they are earning a lot for two products. In a country, in the Philippines, we are rearing bees for honey production, not necessarily for pollination. We don't have much problem in the country since we don't have winter that would put the honey bees in the opposing stage. They are active the year round, and but the problem here is different from that of the temperate countries. Here, there could be some bee decline when the bees are affected by varroa mites. But going back to the role of honeys as pollinators in the Philippines, in our country, if there is no need of augmentative release, there are other insects that are also considered pollinators like flies, and they are present year-round. as I've said, unlike in temperate countries where they have winter, they have fall and winter, wherein insects would start slowing their activity in preparation for this very cold condition. And during the cold condition, there is no reproduction. Insects are just kept in a quiescent stage. They remain immobile to save the energy they have imbibed in the absence of food. And in so doing, the population is limited when spring and summer comes. That's it. Okay, so we have had our discussion on neonicotinoids done, and I would like to request anybody of you who can summarize what we learned in 40 minutes. Anybody? Anybody? Okay, I think Dave would like to answer. Dave, I see that
Yes, ma'am. Yes, ma'am.
your speaker is active, but can you summarize, Dave?
Try na ko, ma'am.
Uh-huh.
Kanang neonicotinoids, ma'am, came from the word kanang neo, kay ma'am, means new siya. Then,
Yes.
around, discovery siya, ma'am, around 1990s. Tapos,
Good.
it is a broad spectrum, pero less toxic siya sa mammals, unlike sa insects. So,
Yeah.
mo-attack siya, ma'am, iyang mode of action sa central nervous system, sa pag-transfer sa mga neurons, ma'am ba. So, tapos mas effective siya nga pesticide kung sa mga insect nga mo ingest siya, ma'am, kanang iyang kanon ba, unlike sa i-absorb lang sa skin or sa kining i-inhale nila ang kining certain chemicals. More siguro to, ma'am. Thank you.
Yeah, very good. You have summarized the topic in short but concise manner. And yeah, that is a very important information you shared with your classmates, especially those who were not present when we started our class. They just joined lately. Okay, some more question or anybody of you that would add items that might have been not included in Dave's discussion a while ago? So none? So that is very important. That it's important for you to learn the mode of action, the kind of activity, and knowing those, it can guide you on what these insects are getting killed by these neonicotinoids. So its activity is more of a systemic in nature, since there is less toxicity when it is administered dermally or it is inhaled. In insects, when it is the integument that would be affected when it is in terms of dermotoxicity. Since the toxicity in the skin or for insects in the integument is less, then the mortality is not necessarily being attributed to the amount of insecticides that are coming in contact with the integument, but rather on the amount of neonicotinoids ingested from the food they eat. Okay? Clearly understood by their students. Were you able to go through with me in the course of my discussion?
Yes, ma'am.
Yeah. Thank you, Glenn. Before I will start my second
Yes,
lecture.
ma'am.
Okay. Thank you, Jessa. How about Trexie? Okay. Or Sunshine? Okay. I know that there are students that keep leave our meeting every now and then. This could be due to interconnectivity. It happens to me. That's why I was looking for, in the morning, I was looking for a better signal. I'm doing my lecture here in my laboratory. The signal in my office is relatively weak. Okay. Will you allow me to proceed to the next lesson?
Yes, ma'am, yes.
Okay, good. Okay, so let's proceed to the next one. It is now on another group of insecticides that are also quite effective.
Fibronil.
Can you see it?
Yes, ma'am.
Okay. This time we are talking another group of insecticides that are based also from natural products. This time it is not from plants like that of neonicotinoids that is based from nicotine. This time it is based on natural products or natural compound present in the insect itself. It is the compounds that are secreted in the endocrine system of the insects that are regulating insect growth and development. The discovery of this compound was based on the discovery of IGRs as another form of insecticide is based on the natural activity of the insects during the course of growth and development. For insect growth regulators, these are the compounds. When we say insect growth regulators, we are referring more of the synthetic based compound, but there are also those natural product based compounds that we can encounter in plants. And for insect growth regulators, these are compounds that disrupt a certain stage of development in an insect growth that can be used as a new approach in insect pest management. This group of compounds now are referred to as insect growth regulators or insect hormone mimics. Why insect hormone mimics? These are now compounds that are derivatives of the insect hormones, insect growth hormones, and they will mimic the activity of these natural insect hormones in terms of insect growth and development. And for this insect growth mimics are the synthetic insect growth regulators. They are capable of interfering insect growth, insect development, and metamorphosis. Those insects that had been treated with this kind of compounds or insecticides, these insects would remain in their immature stages, in its precocious stages, and they don't have the ability to become into adults. They will no longer develop into an adult stage. For IGRs, these are compounds that are highly selective to insects and arthropods, but because they kill through a disruption of growth and development, they would take more time to reduce insect population than conventional insecticides. Even with this characteristic, they are still being recommended for insect control for many reasons. And we have to discuss this later on as we go along with our discussion. Now, for these insect growth regulators, these are also compounds that may inhibit the formation of the chitin required to make a new cuticle for each mold. Now, the insect would not molt without new formation of uh, integument. And these um, insect growth regulators, they may also replace or disrupt the production of juvenile hormones, which in turn controls the molting process. So first, if they would be applied to the insects would retain in its immature forms by mimicking the action of juvenile hormones, or if they are into chitin synthesis, then they will also inhibit formation of chitin as one of the components of the insect integument, and we know that insects should shed off its integument in order to grow, to provide space for the increase in size of insects after molting. Okay. Now, the production of insect growth regulators would not be successful without looking back when this hormones was acting on the insects. Now, the original idea of hormone-based insecticides was founded with the discovery of William in 1956, when he did some experimentations, and one of his experiments on treatment of the pupal stage of an insect by introducing hormone extract into the pupa, and it turned out that the pupa did not develop into a full-grown adult. Instead, the insecticide that was produced after exposure to such kind of extract from the insect itself, this insect produced an intermediate form, part of which is still a pupa, the other part is already an adult stage. And if the insect have this kind of condition, it's no longer capable of survival, and if it will not survive, then the next stage of population build-up, which is the course of which is mating, then there will be no mating would occur, since insects could not survive long enough that mating could occur. And there are also some abnormalities in terms of anatomical features of the insect. The first chemical discovered actually with juvenile hormone activity was farnesol, and this particular compound was extracted from the feces of beetle called Tenebraeo by Schmelik in 1961. And farnesol is actually a compound produced after fusing 5 isoprene units. One isoprene is composed of this 1, 2, 3, 1, 2, 3. Yeah, 5 isoprene units of in order to come up with this sesquiterpene isoprenoid based compound. Why it is called farnesol? If you look at one of the end part, you have there a hydroxyl functional moiety, and for the chemical structure of alcohol, it is R, the residue, and it is connected to an alcohol, a hydroxyl functional unit. This farnesol was one of the bases in developing in developing analogs of juvenile hormones or insect growth regulators. Now, in order to improve this molecule, a lot of, like for example, in order to improve this activity of farnesol, a lot of improvement was done, including the methylation, no, not methylation actually, the esterification of the alcohol part to form methyl farnesoid. Now, it thought that methyl farnesoid is a new compound, it is a novel compound. It is only done through synthesis, but after 3 years of the discovery of farnesol, which was the basis for the production of methyl farnesoid, it was found out again that this product is actually a natural one, and it is the most ubiquitous among the natural juvenile hormones. And this is referred to as juvenile hormones 3. Now here from farnesol, from this product, the methyl farnesoid is developed by substituting the alcohol functional moiety in this part of the molecule, and you can even have substitution with aldehyde or other kind of chemical groups. But for this instance, the alcohol part was now substituted with an ester to form methyl farnesoid. Is actually the condensation of alcohol and acid during the process of esterification. In the process of esterification, water is liberated in order to fuse the alcohol and the acid in it to be incorporated into the molecule. For the novel insecticides that mimic the action of the two insect growth and development hormones, which are 20-hydroxyecdazone and referred to as 20E, and the sesquiterpene hormones, this GH, the methyl farnesoid, these novel insecticides had been developed. In the development of novel insecticides, either this molecule is being based upon or this one. For the development of insect growth regulators, there are 3 kinds of IGRs that are produced and are available in the market. These are the juvenile hormones, the chitin synthesis inhibitors, and the anti-juvenile hormones that would act as an ecdazone derivatives. If it is an anti-juvenile hormones, you would expect that the insect would undergo lots of molting. For the first category of the insect growth regulators, we have the juvenile hormones or the JHS. This group of hormones are of acyclic sesquiterpenoids that regulate insect development, reproduction, diapause, and polyphenism. Polyphenism is a condition wherein insects affected with juvenile hormones produce different forms. Poly meaning many, phenism from pheno meaning appearance. So for polyphenism, you can have insects of different appearances. There are lots of aberrations in the insects. Most insects, by the way, contain only juvenile hormone 3, that is the methyl farnesoid. But there are also other orders of insects that have other kind of juvenile hormones, such as juvenile hormone O, juvenile hormone 1 and juvenile hormone 2, which had been only identified in moths and butterflies. For other hormones, like GHB3, it is a juvenile hormone 3 with two epoxide rings in it. With juvenile hormones, one of the ends is actually containing epoxide ring, but for GHB3, there is now another epoxide ring part of the molecule. And for this kind of hormones, it is only present in dipterans or in flies. Insect juvenile hormones control metamorphosis and insect development. When there is a high level of juvenile hormones, the development of the larvae and nymphs are being prevented or hindered to become into adults. For this particular condition, the immatures would remain as it is. They would not become an adult. While they remain as a juveniles, either as a larva or nymphs, they continue to grow. And sometimes there are large larvae that are produced, which are referred to as super larvae. Monster na siguro in the context of the size of insects. It's already their giant insects. Let's take a look of the different hormones present in the insects under natural conditions. And we have also juvenile hormone analogs. Analogs are derivatives of product juvenile hormones. Now there are 5 natural product hormones, and this JH0, which is a methyl farnesoid, is actually common in almost all insects. JH1 and 3, where can you find them? Where can you find them? Can you still remember? These are common in butterflies, and JH3 is common in dipterans. Oh no, this epoxide, bipoxide. Okay, now if you look at these pictures, can you spot the differences and the similarities? Can you spot where? What are the commonalities in this group of hormones? Can you see the differences? Anybody from the group?
Presence of oxygen, ma'am.
Presence of oxygen. Try to look at in detail the whole structure of the naturally occurring juvenile hormones. There are parts of the molecule that are present in almost all of these hormones, but there are also differences in each of these juvenile hormones. What are they? Can you spot the difference or the differences or the similarities? Let me see. How about Dave? Dave, can you spot where the differences lie and the similarities?
Ma'am, di man gud kayo klaro imong slideshow kay wala man slideshow. Gagmay kayo.
Gagmay kaayo, okay. I will try to check if you can see it. Okay ha? Just a minute. Just a minute. I would try to look at here where this one. How about that one? Can you see it clearly now?
Wala pa, ma'am.
Wala pa?
Wala pa.
Ik- Wala.
Mag-zoom man tala nimo kan. Dave.
Try to zoom it, Dave. No? I try to do it here. Kinsa to can you spot the difference? Anybody of you?
Unsa man ma'am kanang sa insect juvenile hormones o sa
Hormones.
juvenile analogs?
Yeah. Let's talk about
Oh.
first insect juvenile hormones.
Ang main similarities nila is na sila ay wait, RCOOR unsa ester?
It's the ester. Yeah, correct. Kinsa man ning nag-answer?
Contreras ma'am.
Ay, okay. Good. So, Glenn, can you proceed, Glenn?
Ma'am?
Can you proceed?
Yeah, ang difference nila ma'am is sa GH3 kay kuan wala sa first nga panang carbon kay murag sa methyl siya kutob wala siya kaabot sa wala nakwangan og ano.
So ano no, you have indicated the presence of the ester in this last part of the molecule. The first part is the presence of epoxide ring. Yes, but it now varies depending if it contains this ring is attached to a methyl or an ethyl. No? So here. So these are the similarities, this epoxide ring and this part of the molecule. Now the differences is this substitution in any of this part of pin, this isoprene part. Here you have all ethyl in JH0. Here you have only an ethyl in this part. In the second two parts, the one that is attached to the epoxide ring, and also the one in the first carbon with a double bond. Then the difference between JH0 and JH1 is the ethyl is reduced into a methyl. No? Then in JH2, the ethyl here in JH1 is again reduced to become methyl, and and in JH3 the same structure with JH2, but there is now a difference in this part of the molecule, the functional moiety attached to the epoxide ring, wherein you have a methyl and plus an ethyl here, but in JH3 it's only methyl, no longer an ethyl. For JH, the JH with B3 code, the juvenile 3 plus 2 epoxide rings, then the structure is being maintained in JH3, but instead of a double bond here, the first bond here, it is now, instead of an open structure, it is now a closed one. It is an epoxide ring. This double bond has been subjected to epoxidation to produce another ring, the epoxide ring. Is it clear over there? Okay. Can you see me? Or can you see my okay. Can you see?
Yes ma'am.
Okay, good. Now let's take a look on the juvenile hormone analogs. Try to spot the difference again. You compare methoprene with that of JH to the methyl farnesoid. Where's the difference now?
Naghan ba?
Instead, let's go first to the epoxide ring. It is opened to produce a dimethyl methoxy functional moiety. And in the other end, instead of having a methyl, you have now an what is this? Isoethyl. No, it's a dimethyl actually. Dimethyl functional moieties that is attached to this part of the molecule. Then how about hydroprene? There is now a removal of the methoxyl part of the molecule in this part. Then this part here, instead of a methyl, you have now an ethyl. This one is dimethyl. In the methylprene, this is ethyl. No? So instead of a methyl esterification here, it is now an ethyl esterification that occurs in hydroprene. Well, you have another group of insecticides where in this part of the molecule, the one with epoxide ring is being substituted with diacylhydrazine here, like this here and here, and here maintaining the structure of this part of the molecule. But here, instead of maintaining, it is being replaced with a ring in the same manner with this here. Now, these two, methylprene, hydroprene, and phenoxycarb, at least they maintain molecule from the naturally occurring juvenile hormones. Pyroxaphene and diuphenolan, they are now exactly different kind of molecule. What is only retained is in terms of the what you call this, the chain appearance of it, that is now the one that would bind into the receptor sites. But if you look at the structure, if there are lots of modification, what do you think? Does the activity improve or decrease from the natural produced ones? What do you think? Does the activity increase or reduced? Anybody? Of course, it is being reduced. That's why we have the so-called structure-activity relationship. Anything that you are going to alter in the original compound, then it would also produce different activity. Either the activity is enhanced or in here the activity is enhanced in terms of methylprene and hydroprene as well as phenoxycarb. But here, a lot of substitutions in almost all parts of the molecule of the insect juvenile hormones, then the activity would become less and less. It is one of the reasons why there are only three most best known juvenile hormone derivatives or analogs. These are the methylprene, hydroprene, and phenoxycarb. Since these three hormones or analogs, so to speak, retain most of the natural structure of the original naturally produced juvenile hormones in the insect. If you look back, this one, almost none has been retained. Actually, it's a total replacement of all the molecules. I mean, of all the parts of the molecule. Now, these three analogs mimic the juvenile hormone produced in the insect brain. Now, the hormones are produced in the insect brain, and it would dictate now whether the insect would proceed to the next stage of development or not. For juvenile hormone analogs mimic, this would now forces the insect to remain in a juvenile state. Hence, the amount of hormones present is already increased. We have now the natural hormone produced in the brain that are available in the insect, plus the juvenile hormones analogs that are mimic, increasing or enhancing the activity of the juvenile hormone produced in the insect itself. If these juvenile hormone analogs behave in the same manner as the natural juvenile hormones, then the insect is being signaled to remain in a juvenile state. The insect is not being signaled to molt to become to become to undergo molting and grow and develop to the next stage of development. These juvenile hormone mimics cause premature molting and deformation of wings and other reproductive parts. If these things happen, the insects are less likely to reproduce or even become pests. A pest is only considered when the population is beyond the tolerable limit. If it is already beyond the threshold limit and reach the injury level. Now, insects are not yet considered pests even if they are present, but the number is not that much that can cause damage to the plant or to any product where these insects are harboring. Now, the classification of second classification of insect growth regulators. These are the chitin synthesis inhibitors, and the term itself indicates that the synthesis of chitin is being disrupted, and when chitin is not available, then this would prevent the insect from further development through molting. Now, for chitin synthesis inhibitors, the insects are unable to produce or synthesize new cuticle, and if there is no synthesis, the insects will not molt successfully into the next stage. Now, every molting process, a new integument is necessary. The action of the different hormones in terms of molting, as you could still remember in your insect physiology part of this course, when Miss Manilyn explained to you the role of different hormones in the insect body, in which these hormones are produced in the endocrine system and particularly in the brain of the insect. If the amount of chitin is not enough, because chitin inhibitors disrupt its production, what happened? The insect would just remain as it is, no more molting happens. They remain in its precocious stage. We have 4 chitin inhibitors that are produced. We have diflubenzuron, bufropizin, novaluron, and benzileuron. Now here, okay, here look, spot the difference again, why they become chitin synthesis inhibitors. So it is actually based on the steroid structure of the ecdysone, actually. And here you have compounds that are heterocyclics. Yeah, here. And all of them can be bought in the market. They are available, but they are relatively quite expensive. Let's go to the mode of actions of chitin synthesis inhibitors. As you look at the structure, it is a benzoyl hydrazine analogs. Why hydrazine? You have these two hydrazine present here. This is the hydrazine part. It's a fused together look. And the difference is only in the substitution, either on the first benzyl ring or in the second benzyl ring. You did a lot of substitutions here. Or you can have a substitution or a change in this part of the molecule wherein you have a ring. Instead of a benzyl ring, it is now an open type of compound in this part of the molecule. Okay. So here you'd have a lot of halogenation that takes place in the structure. The halogen that is incorporated here is mainly fluorine. In the other kind of compounds, it is mainly chlorine. But here it is most is on fluorine. But we have also here. Yeah?
Ma'am, wa na lagi na kuan ang slides mo murag wa na siya na.
Nag-move? Okay. Pero nakita ninyo.
Naka na ma'am, na-move na ma'am.
So, ako lang itong gikuan, gipadako. Okay? Para makita ninyo.
Thank you ma'am.
Okay. How about this time? You can spot the difference now. No? So in this case, if I would like to ask you, which one is more persistent? Among these four molecules or chitin synthesis inhibitors, which do you think is more persistent? Is it difluvencerone versus bufopricin, or dibenzoron versus novaluron, or tibofbenzoron, or here versus the three, these three versus the three, or here with this? What do you think? Since it is very important, especially when we are going to spray it on the plants, persistence is another factor to be considered. What did I say before? Any compound that is fluorinated becomes more persistent, and it depends on the halogenation that would take place. Here you have two, you have chlorine and fluorine. Here you have also chlorine and fluorine, but more of fluorine here, more than this one. And this one, there are also fluorines here and one chlorine in this molecule. And this one, no halogenation whatsoever. What makes this also toxic is the presence of sulfur here, plus its activity being chitin synthesis inhibitors. Now remember, the insect would have to ingest the material first, and if they were not ingest on the time that the plants are sprayed, and it takes quite some time, what do you expect? So this insect would manifest the effect of chitin synthesis inhibitors or not? What do you think? Can I call anybody of you there? Looking at the structure is it's an important thing to do. In the structure, we have already an idea whether this insecticide or compound is quite effective or not, and how long they will remain in the treated surface. In this case, bubopricin is the least persistent since there's no halogen incorporated here. But this is the most persistent. When you look at how many fluorines are being incorporated versus this kind of compound, here you have both chlorine and fluorine, also this one, but the number of fluorines incorporated is more in this novaluron. It is one of the most effective IGRs actually available in the market. So what is the mode of action of chitin synthesis inhibitors? The benzoyl hydrazine analogs, the one that has two benzoyl rings in it attached with an oxygen, as if they look like that of ethers, but it's quite different. Hydrogen is a combination of two rings actually, and this act like that of the native malting hormone at the molecular level by binding with the ecdysone receptor complex. Here, instead of the ecdysone that would bind with the receptors, it is now the benzoyl hydrazine analogs. With this binding of benzoyl hydrazine analogs as chitin synthesis inhibitors, it would not transactivate a succession of modes, initiating transcription factors that in turn induce the expression of a group of malt-related genes. In malting, it is an interplay of different activities within the insects. Those different hormones that are important in the malting process, and one of which is the ecdysone. Then, during the process of malting, there are other hormones that are involved, but in this case, we are just after of the chitin that has to be produced by the insect in order for the insect to go into malting. Otherwise, if there is new production of chitin as one of the main components of the insect integument, then malting definitely will not proceed. These diacyl hydrazines as a group of compounds under chitin synthesis inhibitors, it is referred to now as ecdysone agonist, since it would inhibit the action of ecdysone for the insect to go into malting. And it depends now on the concentrations actually. If there is not enough, if the concentration is not that much, then the insect would not proceed into malting, since the ecdysone agonist is being hindered. But when there is also much, it would also stimulate the insect to go into more malting actually. So for chitin synthesis inhibitors, the activity is not that direct, but it would affect the production of chitin that has something to do with the malting process of the insect. Okay. So the toxicity of diacyl hydrazine compounds as anti-juvenile hormones, it has this, we go now into the third group of hormones, that is the anti-juvenile hormones or ecdysones derivatives. In this case here, the manifestation of toxicity is via interaction of the ecdysone receptors in many of the susceptible insects. as that of the natural insect's molting hormone, the 20-hydroxyecdysone, meaning to say that the diacylhydrosines as an anti-juvenile hormone in hormones, such analogs would now prevent the insects to become adult stage, and its activity is either preventing molting to occur, or the molting will be accelerated. It depends actually on the amount of these compounds the insect would have. Now the discovery of bis-acylhydrosine ecdysteroid agonist was only accidental in nature. It was in 1983 wherein Room and Haas Company, their scientists were observing that such products this company produced. Room and Haas, by the way, is also kind of pesticide company. They are into herbicide production, and during the process or during the production stage of many of these chemicals produced by this company, one of the compounds that they were producing, this bis-acylhydrosine, it turned out that it has this ecdysone activity, and it is an additional product in their chemicals produced, where this company was able to get also more profits from it. And this company made a lot of modifications that they were able to produce cost-effective analogs. If you look at the structures, this is just simple. It is this fusion of two acyls, the diacylhydrosines, and making some substitutions in one of the rings. This products had been actually giving big revenues for the company, and the activity of this different diacylhydrosine antagonists or anti-juvenile hormones, so to speak, it depends on the substitution, and also in parts of the molecule. For instance, here you have chlorination in this part of the ring. Here it's
Excuse me, ma'am.
Murag
nag-stock up ma'am imong slide.
Nag-stock up na pod. Okay. Okay, I will just use this. How about this one? Yeah, can you see it with this? Because it may stock up when I have to zoom in. Let's just content ourselves with this one, okay? Now, if you look at the halophenoxide with that of tibophenozide, the halophenoxide is the same as tibophenozide, but there is this removal of the ethyl part of the molecule in this one benzyl hydrazine or diacylhydrosine. The ethyl is being removed and substituted by chlorine, and this part of the molecule, there is a methylation that takes place in two of the carbons that are in carbon 1 and 3. It is in the meta position of the carbon here, where the substitutions of methyl occurs. With methoxyphenoside, which is maintaining the tibophenozide part of the molecule, but instead of an ethyl that is being incorporated in this ring, it is actually now a methoxy part of the molecule. that makes it also causing the same kind of activity. But what is important here, this part of the molecule is being maintained that makes it as an ecdison antagonist. And if you are going to look back, the basis of the novel production of IGRs, it is based on the steroid structures of the 20E ecdisone. Getting part of those and making a lot of substitutions and derivatization, then these three compounds were eventually produced. These two, methoxyphenoside and ribofenoside, these are the acyl juvenile hormone antagonists that are quite effective for Lepidopteran insects and Coleopteran insects. Okay, and they are quite effective if it is applied to the plants, especially when these plants are being attacked by chewing insects, either a Lepidopteran or a Coleopteran one. Now, we have here a structure that is quite complex. I know that you are aware of azadirachtin. And azadirachtin is a natural compound, a terpenoid compound, which can be derived from the seeds of neem, Azadirachta indica, which has an IR activity. Now, if you look at the structure, it is quite complex. It is not easy to produce this one. That's why 2 years after the discovery of this very complex molecule, before a successful synthesis was made, it was in 1980. If it is 22 years and 2007, it was in 1985 when this azadirachtin was identified as one of the bioactive components from the neem, and it is a popular organic formulation intended for organic agriculture. And aside from being insect growth regulator, it is also an antifidant type of compound. By the way, I would just like to share with you that azadirachtin was the complete structural elucidation was successfully done by my professor, Professor Krauss, who is a renowned organic chemist. It gave him a lot of awards, and me as one of his advisors, I also got some of those benefits actually. And it is very important, since I would like just to share with you why I mentioned him, since if you go and read information about azadirachtin, then his name would always come out. And it is one of the best organic kind of chemicals, although it can be produced synthetically, but most of the azadirachtin we can buy in the market is not of synthetic in nature. If we will use the synthetic ones, then it becomes more expensive, looking at how it is being developed and the number of years it took before the complete synthesis was achieved. That was in 2007. If one would do synthesis of this, well, it can be successful, but the process in making this one would take a lot of investment, making the product very expensive. The synthetic product, azadirachtin, is more expensive than the natural product. Okay. That's it. And when these IGRs, especially the anti-juvenile hormones, are being used, these synthetic analogs would bind strongly to the receptors, and it will remain in place in the receptor sites of the insect, and it can repress all the down-regulatory genes, such as the ones that are involved for cuticle elaboration, sclerotization of the cuticle. This is the hardening of the cuticle or the integument after molting. The ecdysis, which is the process of molting in the insect. And if all these regulatory genes are downgraded, what happened? There is direct or indirect effect in this one, resulting in developmental arrest of the insect in that kind of state. So for treated larvae, they would go now into a precocious incomplete molt that would now eventually lead to death of an insect. I will just show you some pictures provided by Hamidja and Sultani in Journal of Entomology and Zoology 5 years ago. Here you could see that a larva contains two heads. The mouth parts are also being deformed. Then there is even eye displacement here. It is not normal, as if the insects are being cross-eyed. Then you have an individual, half of which is part of an adult, the other half is still an immature. So that's it. So I think that's all for today's discussion. We have 5 minutes more left, and I think one of you can summarize what is IGR is all about as a new form or alternative method of those conventional insecticide. Another form of killing insects with this kind of compounds, basing from the naturally occurring juvenile hormones in insects. Anybody? Si Glenn, no? I see his speaker is open. Maybe he wants to say something to summarize what we have discussed on insect growth regulators. Well, if you don't, I have one question here that you have to ponder. Can I recommend the use of insect growth regulators? For example, my field is infested with many kinds of insects. Should I use insect growth regulators, or I will opt for the other kind of conventional insecticides? If I'm playing one of your clients, if I will ask you, can you recommend to me, is it wise for me to use insect growth regulators, or should I opt for other conventional form of insecticides? Glenn?
Kuan ma'am, kanang pwede siya i-recommend ang kuan IGR. Because kuan, it is selective ma'am, mainly sa mga arthropods ang kining kanang beneficial nga insects like spiders kay dili man na siya apektuhan, so pwede ra ma'am.
Yeah, very good. That is one of the answers I'm expecting from you. You can recommend, that is on a positive note, but you could also recommend not using it on a negative note. If ever you will say don't use it, then what would be the reasons I would expect from you? Si Edward kaya? Edward? Or this time, I think I have to call ladies. Si Karen? Karen?
Buyaw ta to.
Should I use it? Then you say, okay. Si Koan kaya? Let me see. Isa may mo recommend?
Baka na ko.
Jennifer? Should you should you recommend to me that I will not choose it? And if it is your decision that you will say don't choose it, then I will expect that the answer why. Can you see something? Jennifer, wala siguro. How about uh, Jonaline? Jonaline, are you still there? Okay, since our time is running fast, I can only give you 2 to 3 minutes. Well, the answer could either be yes or no. It depends on the situation in the field. For example, if the predominant pests are more of the defoliators and the damage is just overnight and it takes a shorter period of time when the whole plant becomes defoliated, then I would definitely answer you can recommend the use of IGRs. And you can also recommend this, especially if your insects are becoming more and more resistant to the commonly used conventional insecticides, from chlorinated hydrocarbons up to the last topic we had, especially with neonicotinoids. Okay, those are the answers I want to have during our final exam. Now, we still have 3 topics left and we run out of time. The reason why we were not able to finish it, we are not always on time. And in most cases, we are 30 minutes late. And I did one more meetings to finish 3 more lessons to take. And here in my first meeting, they decided that we will have another session on Thursday evening, that is 7 to 9. If you are not amenable to it, then I will just anyway, the lecture that I will be giving to my former class, they will be posted in the e-learning, and it's up for you to study it by yourselves. But then, okay, Edward.
Excuse me, ma'am. Magklase taon niya sa laboratory, ma'am.
For the laboratory, I think it has already been discussed. Everything had been discussed before. If you want that, we'll meet. But
Exercise 4 manrata kutob ato, ma'am.
exercise
Last time.
4,
Yes, ma'am.
exercise number 5 and 6. Okay, then we can meet this evening at 7 o'clock. We can meet this evening at 7 o'clock. Yeah. And I don't know if others would be amenable to have a laboratory class this evening. If not, then I think you can do it by yourselves. Anyway, it's on formulation. But if you want, then it's all right with me. For exercise number 5, we have discussed up to the labels, right? For exercise number 5, it is the familiarization of the commonly available formulations in the market that you could see, and how they would look like once you are going to mix it with water. Okay, how about the rest of the group? Do you want to have it further discussed this evening with the laboratory exercise? If only Edward is willing to have and would like to attend the laboratory class, then spending an hour or two
Dili na lang, ma'am.
would become a futile exercise. Dili na lang?
Dili na lang, ma'am.
Dili na? Okay. Anyway, the laboratory manual has already been uploaded, and all those characteristics of the different formulations are described in detail. Then it is now for you to imagine how they look like. But then, as an additional assignment for exercise number 6, you're going to go to the aggregate supply and look for those different formulations in the market. Okay?
Sige,
Or
ma'am. Thank you.
and the different groups of insecticides as well. Okay? At least if we don't have class, you will give me time to rest, having a lecture early in the morning until 3 in the afternoon. And after this, I have to attend to another meeting and other activities for the center. Okay? So, thank you so much for giving your precious time and wishing you more productive afternoon after this lecture, and do your assignment, please. And for the lecture that we will have on Thursday, I don't know if you are interested to attend. My 2 lectures schedule, all those who attended this morning from 8 to 10 and the 10:30 to 12:30, they're willing to attend on Thursday evening. I want that the 3 lecture periods, the students from the 3 lecture periods will join the evening class on Thursday. I don't know with this group. If you don't, if you're not interested, then it's fine with me. I have to discuss 3 more lessons. 2 for the remaining lessons that have not been discussed yet is on lesson number 4-7, that is on microbial insecticides, and lesson number 4-8 is on minor insecticides. And the last topic would be on the fate of insecticides in the environment. I don't know if you are interested, but I already made a go with my morning class, those who are attending in the 8 to 12 schedule. Okay, I don't know if you have, but if you cannot if you cannot decide yet, I will just give a link to this class on for the class we will have on Thursday evening 7 to 9. It's an optional attendance actually. Anyway, all the modules had already been uploaded in the e-learning, along with the PowerPoints that I'm using for the lecture. You can access it. Each of those lessons actually can be accessible in the e-learning site. Okay, I think there are no more questions. Let's end our discussion. Let's call it a day, and thank you very much for your attendance. Thank you.
Thank you, ma'am. God bless, ma'am.
You're welcome.
Thank you, ma'am.
You're welcome. You're welcome.
Thank you, ma'am.
Okay. So for this afternoon, there were 4 who were so participative. Okay, good. Thank you.
Antonio, okay. Ay, kuwang deh, kuwang. Ang karaan na ito, ang katong Antonio, sa lahat dito na print ako kutro.
sige, og dili mo mang okay na ni Virgilio Dagar, Y Junior.
Okay naman na, pero pabutangan ko dira po.
Aw. Okay ra no. Abot yung Junior dong kay
Kining-
amo ra ba ni ikuan dito?
Kiyan na eh.
Oh, tiyan na tiyo.
Ayan.
Kay amo ra ba ni send dito.
Usa may middle name ani? Dagar ni siya. Six.